Lesson we talked about real zeros of a polynomial function. A real zero corresponds to a real x-intercept where the graph of the function crosses the x-intercept. In the first part of this lesson, we will talk about the complex zeros of a polynomial. Now, what does complex zeros means? Well, the very definition suggests that it is not real. That means that zero does not correspond to a point where the graph of the function cut the x-axis, but somehow it is there and it is imaginary. Alright, let's consider the polynomial function x squared p of x equal to x squared plus 4. What are the zeros of this function? What are the values of x which will make the polynomial x squared plus 4 equal to 0? Let's find out if there are any values of x that will make x squared plus 4 equal to 0. Well, if x squared plus 4 equal to 0, then x equal to plus or minus square root negative 4. Is that right? Because x squared equal to negative 4, therefore x has two values, plus or minus square root 4. Now, this can be written as square root negative 4 can be written as negative 1 times positive 4. So, square root of negative 4 can be written as square root negative 1 times square root 4. That will be 2 square root negative 1. Now, what is this quantity, square root negative 1? It is not real. It is an imaginary number. So, square root negative 1 is not a real number. Now, it is an imaginary number and is represented by the lowercase I. So, the lowercase I stands for square root of negative 1. Tell me, if the lowercase I is square root negative 1, what is I squared? I squared is square root negative 1 multiplied by square root negative 1. And what does that give you? That is I. So, well, is it I? I squared is negative 1. You see, I is square root of negative 1. So, I squared is square root negative 1 times square root negative 1. That is negative 1. That's right. So, x equal to plus or minus 2i. That means when x equal to 2i, the polynomial function is 0. And when x equal to negative 2i, also the polynomial function is 0. That means these two numbers, positive 2i and negative 2i, are called the imaginary zeros of x squared plus 4, the polynomial x squared plus 4. Now, a number of the form a plus bi is called a complex number. Now, a complex number has a real part, a is the real part, and an imaginary part, bi is the imaginary part. Now here, we got x has two values, and both are imaginary. So how do I write these zeros in the complex form? So the zeros of p of x equal to x squared plus 4 are complex, and look at the way we can write it. X equal to 0 plus 2i is one complex 0. Now the real part of this is 0, and the complex part, the imaginary part, is 2i. So the first 0 of this polynomial function is x equal to 0 plus 2i. Rather than saying it's equal to 2i, we need to say it is 0 plus 2i, because that is the complex number form. A complex number has a real part and an imaginary part. Alright, what is the other 0? X equal to 0 minus 2i. And you see, these two always come in pair. 0 minus 2i is called the conjugate of 0 plus 2i. That means if 0 minus 2i is a complex 0 of a polynomial function, then 0 plus 2i will also be a complex 0. In other words, these conjugates, the one is called the conjugate of the other. They always come in pair. Complex zeros always come in conjugate pair. In other words, x equal to 2i alone cannot be a 0 of a polynomial function. It has to be 2i, positive 2i, and negative 2i. X equal to 0 plus 2i and x equal to 0 minus 2i both come in pairs. If one is a 0, the other also is a 0 of the same polynomial function. So, p of x equal to x squared plus 4 has no real zeros. What does that mean? It means that the graph of this function will not cut the x-axis. But it has complex zeros because there are imaginary numbers that will make the polynomial equal to 0. That's the meaning of complex zeros. Alright, you can see this is the graph of p of x equal to x squared plus 4. It doesn't cut the x-axis, therefore it has no real zeros. The complex zeros are not manifested by any form in the graph. Alright, now tell me, we answered this already. What is the value of I squared? Knowing that I equal to square root of negative 1. So I squared will be square root negative 1 times square root negative 1, which is negative 1. I squared is negative 1. What is I cube? I cube is square root negative 1 times square root negative 1 times square root negative 1. Well, if you multiply the first two square root negative 1s, you get negative 1. And the last square root negative 1 is I. So this can be read as negative I. Is that right? So this will be I times I is I squared times square root negative 1. And I squared is negative 1. So it will be negative 1 times square root negative 1. But square root negative 1 is I. I times negative 1 is negative I. So I cube is negative I. How about I to the power of 4? I to the power of 4, watch here. I to the power of 4 is I squared times I squared. Negative 1 times negative 1 is positive 1. So you must be able to write the values of I squared, I cube. Tell me, how about I to the power of 7? What is the value of I to the power of 7? Well, I to the power of 7 is I to the power of 4 times I cube. And since I cube is negative I, and I to the power of 4 is 1, I to the power of 7 is negative I times 1, which is negative I. How about I to the power of 8? I to the power of 8 is I to the power of 4 times I to the power of 4, which is 1. Okay, now find the values of I to the power of 5, I to the power of 11, and I to the power of 22 on your own. Well, I'll give you a clue. See, let's take I to the power of 22. You know that I to the power of 4 is 1. So, first of all, how many 4s can be taken out of 22? You see, 4 times 5 is 20. That means you can take out 5 4s. And each of those 4s is a 1. That means this is actually 1 times I to the power of 2, because I to the power of 20 is 1. So this is I to the power of 20 times I to the power of 2, which is 1 times I to the power of 2, I to the power of 2 is negative 1. So I to the power of 22 also is negative 1. That's right. Now, look at this statement. Every polynomial of degree n greater than 0 has n linear factors. Now, what does that mean? Now, look at our polynomial that I gave you earlier. P of x equal to x squared plus 4. Can you factor that? Well, you can actually, because you know it has complex zeros. The complex zeros can be used to factor the polynomial. For example, if 0 plus 2i is a 0 of the polynomial, then x minus 2i is a factor. Now you notice that we don't use the real part there, because the real part is 0. So, if 0 plus 2i is a 0 of the polynomial, then x minus 2i is a factor of that polynomial. In the same way we talked about in the last class, if x equal to 2 is a 0 of the polynomial, then x minus 2 is a factor of the polynomial. In the same way, if 0 plus 2i is a factor of the polynomial, x minus 2i is a factor. Similarly, 0 minus 2i is a 0 of the polynomial, then x plus 2i is a factor. That means you can write x squared plus 4 equal to x minus 2i times x plus 2i. That's right. So what is x minus 2i times x plus 2i? Can you multiply that out? This is of the form a minus b times a plus b. What is a minus b times a plus b? The square of a minus the square of b. So this will be x squared minus 2i all squared. A squared minus b squared. That will be x squared minus 2i all squared. Alright, what is that? Look at that. That will be x squared. What is this? 2i all squared. Now 2 squared is 4 and I squared is negative 1. So if you square 2i, it will be 2 squared times I squared. 2 squared is 4, I squared is negative 1, so that will be negative 4. That gives you x squared minus, this is negative 4, and that will be x squared plus 4. So x squared plus 4 is x minus 2i times x plus 2i. Those are two linear factors of this polynomial. A polynomial of degree 2 has two linear factors. A polynomial of degree n has n linear factors. Alright, let's now use synthetic division to divide x cubed minus 3x squared plus x minus 3 by x minus I. Well, if x minus I is a factor of this, then the remainder will be 0. Is that right? Okay, so x minus I is the divisor. Now, you recall the method of synthetic division? Tell me, or talk to yourself in your mind. What are the coefficients that we first pick of the dividend? Is it x cubed, x squared, x, the constant term? All the terms are there. So pick the coefficients, 1, negative 3, 1, negative 3. And now use your horizontal line and the vertical line and tell me what is the number you will use over here to the left of the vertical line. If x minus I is the divisor, if x minus I is a 0, if x minus I is a factor, then x equal to I is a 0. So the number we will write here is the opposite of this negative I here, so it must be positive I, the number here. Alright, let's go through this. What is the first step again? Bring down the 1 and multiply 1 with this number. 1 times I is 1i. Add the 2 together. This will be negative 3 added to I is negative 3 plus I. Now multiply. You've got to be very agile in your mind, alright? Be very active. So multiply here. I times negative 3 is negative 3i. And I times I is I squared. And I squared is negative 1. So look at this. That will be negative 1 minus 3i. There you go. Negative 3i minus 1. I times negative 3 is negative 3i. I times I is I squared, that is negative 1. Alright, now add these two. Negative 3i minus 1 added to 1. 1 and 1 will cancel. That will be negative 3i. And now multiply negative 3i with this I. What do you get? Negative 3i squared. Alright, again think about it. Negative 3i squared. I squared is negative 1. So it will be negative 3 times negative 1. That will be positive 3. Write it below negative 3. I hope you understood that. Negative 3i squared is negative 3 times negative 1, which is positive 3, and the remainder is 0, which means x minus I is a factor of this polynomial. Alright? And what is the remaining factor? If this is one factor, what is the remaining factor? The remaining factor is obtained from here. Now, the polynomial is of degree 3, therefore the remaining factor will be of degree 2. So this is the leading coefficient, 1x squared, and what's the coefficient of x? Negative 3 plus ix. That's right. And what is the constant term? Minus 3i, and this is the remaining factor. So the remaining factor is x squared plus negative 3 plus I, x minus 3i. Alright, another one. If p of x equal to x squared plus 2xi minus 10, find p of 2 minus I. Find p of 2 minus I. Find the value of the polynomial when x equal to 2 minus I. Well, what all we need to do is to do a synthetic division with 1, 2, negative 10. And what's the number that will go in there? That will be 2 minus I. That's right. In order to find p of 2 minus I, we do a synthetic division with 2 minus I. Alright, bring down the 1 and multiply 1 with 2 minus I. What is 1 times 2 minus I? That will be 2 minus I, and write it below 2I. Alright, add them together. 2I added to 2 minus I is what? 2I plus 2 minus I will be 2 plus I. Is that right? Yes. And now multiply. Alright, tell me, what is 2 minus I multiplied by 2 plus I? You must now be getting very quick with these kind of multiplication. Look at that. A minus B times A plus B is A squared minus B squared. So it will be 2 minus I times 2 plus I is 2 squared minus I squared. Alright, tell me, what is minus I squared? I squared is negative 1. Minus negative 1 is plus 1. So this will be 2 squared minus I squared, which is 2 squared plus 1, which will be 5. Alright, spend some time on your own. Try to multiply. I'll do that one more time. 2 minus I times 2 plus I is 2 squared minus I squared. And 2 squared minus I squared is minus 1. So minus I squared is minus negative 1. So that will be 2 squared minus negative 1, which is 2 squared plus 1, which is 5. Alright, negative 10 added to 5 is negative 5. And therefore, the remainder will be what you want. P of 2 minus I will be therefore negative 5. Okay, let's do another one. Find the degree and zeros of the polynomial. Now watch here. The polynomial is given in the factored form. 3 times x plus 5 to the power of 3 times x squared plus 6 times x plus 4i times x minus 4i. Now look at that. The complex zeros come in pairs. Now state the multiplicity of each zero. How do you find the degree of this polynomial? Alright, tell me. Now listen to me carefully. If I have a polynomial x plus 1 times x squared plus 1, what is the degree of that? There are 2 factors, x plus 1 times x squared plus 1. The degree of the first factor is 1. The degree of the second factor is 2. All you need to do is add those 2 degrees. You see, x times x squared is x cubed. So when you expand that, the first term will be x cubed. The degree of that polynomial will be 3. In other words, if I give you a polynomial in terms of the product of their factors, what all you need to do is find the degree of each factor and then add all those degrees. Alright, tell me, what is the degree of the first factor? X plus 5 to the power of 3. Because it is raised to the power of 3, the degree of the first factor is 3. The degree of the second factor is 2, x squared. The degree of the third factor is 1. The degree of the fourth factor is 1. So the degree of the polynomial is the sum of the degrees of each factor. That would be 3 plus 2 plus 1 plus 1, 7. That's right. In other words, if you multiply these factors out, the first term will be some number multiplied by x to the power of 7. Alright. Now, what do we want to find? Find the degree and all the zeros of the polynomial function. Now, how do you find the zeros of the function once the polynomial is factored? Remember, 0 of a polynomial is the value of x that will make the value of the polynomial 0. So, if the polynomial is given to you as a factored form, set the polynomial equal to 0. Now, when the product of several factors equal to 0, it means each factor equal to 0. So what we do is take each of the factors and set it equal to 0. Now I want you to notice here, there is a factor that is 3 there. Now can 3 be equal to 0? No. That means if a polynomial is multiplied by a constant number, it will not change the zeros of that polynomial. So we don't need to worry about that. First we take x plus 5 and set it equal to 0. X plus 5 equal to 0 gives x equal to negative 5, and x equal to negative 5 occurs how many times? 3 times, because x plus 5 times x plus 5 times x plus 5, each of those x plus 5 needs to be put equal to 0, and each will give you a value x equal to negative 5. So x equal to negative 5 is a 0 of multiplicity 3. Alright? X squared plus 6. The next factor is x squared plus 6. Now tell me, what does that yield? X squared plus 6 equal to 0 gives, what are the values of x that will satisfy that equation? This will be x squared equal to negative 6, or x equal to square root plus or minus square root of negative 6, which will be plus or minus square root 6i. There you are, x squared equal to negative 6, or x equal to plus or minus square root 6i. Remember, this I is not inside the square root. It is plus or minus square root 6i. Now, this gives you two conjugate pairs of complex zeros. What are the two conjugate pairs of complex zeros? If x equal to positive square root 6i is an imaginary zero, that means 0 plus square root 6i is a complex zero. So x equal to 0 plus square root 6i and x equal to 0 minus square root 6i. These are the two complex zeros that come from here. Okay, so we found 3 zeros from the first factor, 2 from the second factor, and now what is the zero that this factor give you? X plus 4i equal to 0 gives x equal to negative 4i, and x equal to negative 4i gives x equal to 4i, and these are conjugate of each other, 0 minus 4i and 0 plus 4i. So the conjugate pairs are 0 plus 4i and 0 minus 4i. So we now found all the zeros of the polynomial and state the multiplicity of each zero. We found that x equal to negative 5 is of multiplicity 3. Alright? Now, look at the graph of that. What is the behavior of the graph at x equal to negative 5? You see, it's got a multiplicity 3. Now here, I just drew the graph with the normal window, and look at this. It looks like the graph is crossing the x-axis at x equal to negative 5. But what is its actual behavior when it crosses the x-axis, when you have a zero of multiplicity 3? Will it really cross the x-axis just as you see? Well, you can see the behavior if you change the scale and draw the graph. Look at this. This is x equal to negative 5. Now, if you draw the graph on a scale like, let's say, negative 50 to 0, and you will see the behavior here. On the x-axis, it is not really crossing readily. The graph is almost along the x-axis for a considerable length of time. And that is the significance of x equal to negative 5 of multiplicity 3. At negative 5, it is really not crossing. It is sort of lingering around at x equal to negative 5. Okay. Now, finding the complex zeros of a polynomial function. How do we find the complex zeros of a polynomial function? Now, what we will do is, we will use TI-84. Now, TI-84 only gives you the real zeros. So we can actually use TI-84 to find the real zeros, and then maybe we hunt for the complex zeros. The TI-84 will not do the complex zeros. The complex zeros will tell you that they're not real. Alright, first we will use TI-84 to find the real zeros. Now, once we know the real zeros, we can use them to find the remaining factor. That means we can find the real factors, and the real factors can be used to find the remaining factors. Let's see how that can be done. So use the real zeros to obtain the corresponding factors of the polynomial. Then use synthetic division to obtain the remaining factors that correspond to the complex zeros. Well, we will do a couple of examples and then you will understand it. Now, setting these factors to 0 will give the complex zeros. So once we are able to find the complex factors, we can set them to 0 to find the complex zeros. All right, let's do an example. Find the real and complex zeros of f of x equal to x cubed minus 2x squared plus 4x minus 8. Now, how do we use a calculator to find the real zeros? What are the steps that we do? We use the application menu, is that right? So, we go through that once again, press APPS and press the down arrow 11 times to access polysymult, is that right? Press enter a couple of times and enter the degree of the polynomial, and in the screen that appears, put in the coefficients A3, A2, A1, A0 as 1, -2, 4 and -8. But we have done these before, so you must be able to do that on your own now. Now here, the calculator gives you x1 equal to 2 is a real zero, x2 and x3 are non-real. They are complex zeros. The calculator will not give it to you. But this is enough. We know that x1 equal to 2 is a real zero. If x1 equal to 2 is a real zero, it means x minus 2 is a factor. So x equal to 2 is a real zero, means x minus 2 is a factor of the polynomial. Now we use synthetic division using what number? This 0, 2 on these coefficients. Alright, let's do that. Let's pick the coefficients 1, -2, 4, -8. Horizontal line, vertical line, and use the real zero that we have, that is 2. Okay. Bring down 1. 1 times 2 is 2. Write it below the -2. Add -2 to 2. That will be 0. 2 times 2. 0 times 2 is 0. Write that 0 below 4. 4 plus 0 is 4. Now 4 multiplied by 2 is 8. Write 8 below. That's where. What's the remainder? 0. Of course we expect 0. Is that right? Because we know x minus 2 is a factor. X equal to 2 is a 0. Okay. Now x minus 2 is a factor. Now what is the remaining factor? If the polynomial is of degree 3, the remaining factor must be of degree 2. So this is 1x squared plus 0x plus 4 is the remaining. That'll be 1x squared, 0x plus 4. Therefore, the remaining factor is x squared plus 4. And now you can find the complex zeros of this, setting this equal to 0. And x squared plus 0, x squared plus 4 equal to 0 gives, we have done that before. Will give you x equal to plus or minus square root -4. And therefore the complex zeros are x equal to 2i and x equal to -2i. Well, these are the imaginary zeros. The complex zeros are 0 plus 2i and 0 minus 2i. And so, how do we answer the question? What are the real and complex zeros? The real zero is 2. And the complex zeros are 0 plus 2i and 0 minus 2i. Remember, the complex zeros always come in pair. The complex conjugates. Alright, so x minus 2i and x plus 2i are factors of this polynomial. So what are the linear factors of this polynomial? X minus 2 is the linear factor. X minus 2i is the linear factor. X plus 2i is a linear factor. Always remember, a third degree polynomial has 3 linear factors. Alright. Another one. Find the real and complex zeros of f of x equal to x cubed minus 3x squared plus 3x minus 1 times x squared plus 1. When this polynomial is given as a product of two factors, tell me what is the degree of this polynomial? The degree of the first factor is 3. The degree of the second factor is 2. Therefore, the degree of the polynomial is 5. So, we need to find the real and complex zeros. First of all, we can take the last factor, x squared plus 1, and set it equal to 0 to find a pair of complex zeros. Alright, x squared plus 1 equal to 0 gives, tell me what does that give? X squared plus 1 equal to 0. X squared equal to negative 1. X equal to plus or minus square root negative 1. And square root negative 1 is your I. Therefore, x equal to plus or minus I is a pair of imaginary zeros for that. The complex zeros are 0 plus I and 0 minus I. Now, use use the calculator TI-84 or 83. Now remember, not all TI-83 has the application menu that we want. Only, I think, the silver edition has that. So you must endeavor to use a TI-84. That is more appropriate. So use TI-84 to find the real zeros of this. So what do? Press application. Go down 11 times to polysymult. Enter. Until you find a screen where you got to enter the degree. Enter the degree 3. And enter the constant numbers, which is 1, negative 3, 3, and negative 1. And solve. You will get x1 equal to 0.9999 and so on. What is that? 0.9999. It's actually 1. So x equal to 1 is a real zero. And there are 2 zeros for this polynomial which are not real. So what do? Use x equal to 1 and do a synthetic division on this polynomial to find the remaining factor. Alright, let's use synthetic division. First of all, write down the coefficients, which will be 1, negative 3, 3, negative 1. The horizontal line, the vertical line. Since we know that x equal to 1 is a real zero, we use that for our synthetic division. Alright, you can do that on your own now. Bring the 1 down. 1 times 1 is 1, right below negative 3. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. Write it here. 3 added to negative 2 is 1. 1 times 1 equal to 1. And the remainder is 0. Which means we know that x minus 1 is a factor. Alright, tell me, what is the remaining factor? That is, when this polynomial is divided by x minus 1, what is the result? The result is the synthesis of degree 3. This will be 1x squared minus 2x plus 1. That's right. 1x squared minus 2x plus 1. This is the remaining factor. Now, how do we find the complex zeros of that? Well, the calculator doesn't give you that, but you know that x minus 2x plus 1, is it x minus 1 all squared? Yes, x squared minus 2x plus 1 is x minus 1 all squared. If you want to expand it, it will be x squared minus 2x plus 1. Alright, that means x minus 1 times x minus 1. So x minus 1 equal to 0 gives x equal to 1. And similarly, the next x minus 1 also gives you x equal to 1, which means this is of multiplicity 2. Well, so here x squared minus 2x plus 1 is x minus 1 all squared, and its zeros are x equal to 1 of multiplicity 2. So what are the real zeros? The real zeros are x equal to 1 of multiplicity 3, because the calculator gave you this. Now, it's only if the zeros occurs in multiples, it gave you only 1. But actually, x equal to 1 occurs 3 times. So x equal to 1 is of multiplicity 3. And look at the way the graph goes. The multiplicity 3, you see, the even multiplicity, I hope you remember these. The zeros of even multiplicity means the graph will not cross the x-axis. It will touch and return. But odd multiplicity, the graph will cross the x-axis. But because it is multiplicity 3, you can see the graph lingers on the x-axis for a certain length of time. Right. Now, x equal to 0 minus I and 0 plus I are the complex zeros. So x equal to 0 plus I and 0 minus I are the complex zeros, and x equal to 1 of multiplicity 3 are the real zeros. Alright, another one. Find the real and complex zeros of p of x equal to x squared plus 7x plus 10 all squared times x squared plus 6x plus 10. Tell me, what is the degree of this polynomial? The degree of the first factor is, look at this, x squared is squared. So that is x to the power of 4. This is of degree 4. And the second factor is degree 2. So the degree of the whole polynomial is 6. Well, first of all, we say x squared plus 7x plus 10. Can you factor it? I showed you a quick way to factor a polynomial in the last class. Now, do you remember how to do that? Now, this is what I showed you in the last class. You want to factor a polynomial, first factor the first term x squared and write it as x times x, and draw these lines across, and then factor the last term, positive 10. Well, positive 10 can be factored in several ways. 10 times 1, negative 10 times negative 1, 5 times 2, negative 5 times negative 2. Now the clue comes in the middle term. Look at this. The middle term is positive 7x. Now positive 7 can be obtained by adding 5 to 2. So the obvious choice for that last factor, the last term, positive 10, is plus 5 times plus 2. Write them below there like that. And now look at this, multiply 5x, 5 times x, times 2 times x. Now add them together, 5x added to 2x is 7x. Now, that's a skill that you need to. Once you write the factors of the first term as x and x, the factors of the last term as 5 and 2, multiply across. 5 times x is 5x, added to 2 times x is 7x. When you do that, you must get the middle term. 5x plus 2x is 7x. So you need to do this by trial and error. That means if you factor 10 as 10 and 1 or negative 10 and negative 1, you will never be able to produce that middle term. So do this by trial and error. Now, what are the factors now? The first factor is x plus 5, and the second factor is x plus 2. So x squared plus 7x plus 10 is x plus 5 times x plus 2. And you must be able to do this on your own now. We will need that as we go on. Okay? Alright, now once we have factored it, we can now set each factor to 0. But again, you must notice that we factored x squared plus 7x plus 10. And in the given polynomial, that whole thing is squared. Therefore, if x squared plus 7x plus 10 is x plus 5 times x plus 2, then x squared plus 7x plus 10 all squared will be x plus 5 squared times x plus 2 squared. Is that right? Okay. Now, that means if you put the first factor to 0, that is x plus 5 times x plus 5 equal to 0, it will give you x equal to 5 of multiplicity 2. X equal to negative 5 occurs 2 times. Similarly, x plus 2 equal to 0 gives you x equal to negative 2 of multiplicity 2. Therefore, we get now actually 4 zeros. X equal to negative 5 of multiplicity 2, x equal to negative 2 of multiplicity 2. Now we go to the next one, which is x squared plus 6x plus 10. Now, can you look at this and tell me whether you can factor it the way I just showed it to you? Now, how do you look and see? Now, this is the way. Let me show it to you. Over here, I can factor x, and the last term is 10. Now, is there any way you can factor 10 and multiply across, add, and get positive 6? No, you cannot. Because 10 is 5 and 2, or 5 times 2, or 10 times 1. 5 and 2 added will not give you 6x. 10 and 1 added will not give you. So this cannot be factored. In other words, it has no real zeros. Alright. So what we see here on the calculator, I put it on the calculator for solving, and the calculator says there are no real zeros. So what do? We can actually solve this using the quadratic formula. So x squared plus 6x plus 10 equal to 0 can be solved using the quadratic formula. What is the quadratic formula? You got ax squared plus bx plus c equal to 0. Do you remember that? Ax squared plus bx plus c equal to 0 gives you a equal to 1, b equal to 6, and c equal to 10. And what is the quadratic formula? X equal to negative b plus or minus square root b squared minus 4ac all over 2a. And put in the values there. That will be negative 6 plus or minus square root b squared is 6 squared, that is 36, minus 4a, a is 1, times c is 10, all over 2a. Alright? And that will be negative 6 plus or minus 36 minus 40 all over 2. You can see why there is no real zeros. You can see the quantity inside is going to be negative. And that will be negative 6 plus or minus square root 36 minus 40 is negative 4 over 2. And what is square root negative 4? You must tell me immediately. Square root negative 4 is 2i. So it will be negative 6 plus or minus 2i. Because there is a plus or minus here, you don't need to use another plus or minus. So it will be negative 6 plus or minus 2i divided by 2. And this is actually 2 zeros. Is that right? Now, let's factor out a 2 from the numerator. That will be 2 times negative 3 plus or minus I all over 2. And the 2's will cancel, giving us negative 3 plus or minus I. So 1 0 is negative 3 plus I, and the other is negative 3 minus I. X equal to negative 3 plus I and x equal to negative 3 minus I are two complex zeros of this polynomial. That means this whole polynomial has how many zeros? There are 4 real zeros. X equal to negative 5 of multiplicity 2, x equal to negative 2 of multiplicity 2, x equal to negative 3 plus I, x equal to negative 3 minus I are two complex zeros of this polynomial. So altogether there are 6 zeros of a 6th degree polynomial. Now, can you describe how the graph of this function will look like? Any idea how the graph of this function will look like? Now, we have talked about the end behavior, haven't we? The end behavior of graphs we have talked about. Now, this is a 6th degree function. That means the degree is even. Now, when the polynomial is of even degree, the graph of the function, do you remember, will decrease on the left and increase on the right. Is that right? Did I get it right? Check it. I may not be always right. So, an even degree, that is, this is the 6th degree, so it must decrease on the right and increase on the, decrease on the left and increase on the right. Now, it has a 0, negative 5 of multiplicity 2, a 0, 2 of multiplicity 2. Is that right? Yes, that means the graph must decrease, touch the x-axis at x equal to negative 5, and then go back, increase, it will reach a maximum, return, and which is the other 0. X equal to negative 2. So it will touch x equal to negative 2 and return and increase. That's how it should behave, I think. So the graph must decrease, touch the x-axis at x equal to negative 5, then turn back, increase, reaches the maximum, turn back, and touch the x-axis at x equal to negative 2, and go back. Alright, so the degree of the first factor is 4, and the degree of the second factor is 2, therefore the degree of the polynomial is 6. We talked about it. The degree is even, and the leading coefficient is positive. Therefore, the graph will decrease on the left, touch the x-axis at x equal to negative 5, and turn back and increase. It will reach a local maximum, then turn back, decrease, touch the x-axis at x equal to negative 2, and turn back and increase again. Alright, let's graph it on the calculator. Put down the function as you see it, and use this window and look at the beautiful graph. The graph decreases on the left, touches the x-axis at x equal to negative 5, turns back, it increases to a local maximum and then decreases to touch the x-axis at x equal to -2, then turns back and increases on the right. You see, you can predict the behavior there and sketch the graph on your own without any other information. Okay. Tell me, what is the y-intercept of this graph? What is the y-intercept? You can look at this and tell me. Write it down in your book. What is the y-intercept? Y-intercept occurs. Sorry. Y-intercept occurs when x equal to 0. All right. Put x equal to 0 in the first factor. 0, 0 plus 10. That gives you 10 squared is 100. And times the second factor when x equal to 0, that will be a 10. That will be 100 times 10, it will be 1,000, is that right? Where it cuts, you can see here, it increases and goes all the way and cuts the y-axis at y equal to 1,000. That's right. All right, next one. Find a polynomial p of x of the lowest degree with its leading coefficient 1 that has the following zeros. All right? Square root 2i of multiplicity 2, negative square root 2i of multiplicity 2, and 4 of multiplicity 3. You need to find the polynomial form of it. Well, you know that if x equal to r is a 0 of the polynomial, then x minus r is a factor of the polynomial. So x equal to square root 2i correspond to the factor x minus 2i. If x equal to square root 2i is a 0, then x minus square root 2i is a factor. Now please understand this is not square root 2i, but square root 2 times I. Now because square root 2i is of multiplicity 2, the factor occurs twice. So x minus square root 2i all squared is a factor of our polynomial. I hope you understand that. Similarly, we got negative square root 2i is a 0. Therefore, what is a factor of the polynomial? It will be x plus square root 2i. So x equal to negative square root 2i of multiplicity 2 correspond to x plus square root 2i all squared. So you got x minus square root 2i all squared is a factor of the polynomial. X plus square root 2i all squared is also a factor of the polynomial. Then we have 4 of multiplicity 3. If 4 is a 0 of the polynomial, then what is its factor? If 4 is a 0, then x minus 4 is a factor. And it occurs how many times? 3 times. That means x minus 4 times x minus 4 times x minus 4 are factors. Or it will be x minus 4 to the power of 3. And now to obtain the polynomial, what all we need to do is multiply all these factors. In other words, the polynomial will be x minus square root 2i all squared times x minus square root 2i, well this is minus, that is plus, times x minus 4 all cubed. So here is our polynomial. P of x is x minus square root 2i all squared times x plus square root 2i all squared times x minus 4 all cubed. Alright, now how do we multiply this? Now look at the way I wrote my next step. I wrote x minus square root 2i times x plus square root 2i times x minus square root 2i times x plus square root 2i. Did you understand that? I wrote this as x minus square root 2i times x minus square root 2i. And this is x plus square root 2i times x plus square root 2i. And then redistributed, look at this, x minus square root 2i times x minus square root 2i, x plus square root 2i times x plus square root 2i. But why did I write like this? I combine them in such a way that I've got the form, look at this, a minus b times a plus b. This is of the form a minus b times a plus b, and this is also of the form a minus b times a plus b. Now, what is a minus b times a plus b again? It is square of a times the square of b. So this will be square of x times the square of the quantity square root 2i all squared. That's right. Similarly this. That is the advantage of writing them like this. And so look at this. I expanded this. X minus square root 2i times x plus square root 2i is the square of x minus the square of this quantity. The square of 2 is 2. The square of I is I squared. So the product of these two factors is x squared minus 2i squared. And the same for the next two factors. It is also x squared minus 2i squared times our real factor x minus 4 all cubed. Alright, you need to look at and practice this on your own. A very important skill. Alright, tell me now, what is I squared? I squared is negative 1. So what is negative 2 times negative 1? It is plus 2. So this factor is x squared plus 2. This also is x squared plus 2. So that becomes p of x is x squared plus 2 times x squared plus 2 is x squared plus 2 all squared times x minus 4 to the power of 3. So this is the polynomial that has square root 2i of multiplicity 2 and negative square root 2i of multiplicity 2 and 4 of multiplicity 3 as its zeros. I want you to do this on your own and practice the skill required to do this. Alright, another one. Find a polynomial p of x of the lowest degree with its leading coefficient 1 that has the graph shown on the right. What is the lowest degree of this polynomial? Well, if you watch this, in the first lesson on polynomial we said a polynomial of degree n, the maximum number of turning points is n minus 1. That means how many turning points this has? There's 1 turning, 2 turnings, 3 turnings. Since there are 3 turnings, we can say the polynomial can have a degree 4. And then you notice that the graph is decreasing on the left and increasing on the right. That is the sign of even degree, is that right? Even degree polynomial with a positive leading coefficient. So a lot of information. And you know there is an x-intercept here, an x-intercept here, an x-intercept there. There are 3 real zeros of the polynomial. We can now use all this information to write the polynomial. Since it has 3 turning points, we can say the degree of the polynomial is 4. Now what is the sign of the leading coefficient? Because it is decreasing on the left and increasing on the right, the sign of the leading coefficient is positive. Alright, what are the real zeros of the polynomial? Well, the graph is not really drawn very well. I would say x equal to negative 3 is a 0 of multiplicity 1. That means x plus 3 is a factor. If x equal to negative 3 is a 0, then x plus 3 is a factor. There you are. X equal to 1 is a 0 of multiplicity 2. How do you know it's multiplicity 2? You can see the graph doesn't cross at x equal to 1. It turns back. So you can say x equal to 1 is a 0 of multiplicity 2. What is the corresponding factor? It will be x minus 1 times x minus 1, or x minus 1 squared is a linear factor of p of x. And then x equal to 4 is a 0 of multiplicity 1. That corresponds to the factor of x minus 4. And therefore, what is our polynomial? Our polynomial is x plus 3 times x minus 1 squared times x minus 4. And I drew the graph of that, and look at this. Aren't they similar? You see, looking at the graph, the amount of information you can obtain about a polynomial function is phenomenal. And I think you should really now enjoy. This is the time you must really begin to enjoy your pre-calculus course. It's a very, very interesting part of the course. All right, I will continue with the rest of this lesson in the next part.